Hi everyone, in this video we are going to continue our work with factoring and build on that by using factoring to help us solve quadratics with the addition of another property called the zero product property. So in this video you are going to see more practice with factoring polynomials using a variety of methods, and after we factor a polynomial we are going to apply what's called the zero product property to find the solutions of the quadratic equation or to solve it. So let's look at a couple of ideas. The first really important idea about solutions is that quadratics can have 0, 1, or 2 real solutions. If you think about it, the word solutions, remember, means x-intercepts. So when we solve these algebraically, we're just looking for the x-intercepts without graphing. So if we think about graphing, if a quadratic has no real solutions, that means it just doesn't have any x-intercepts. If it has one real solution, that means it has one x-intercept. And if it has two real solutions, it means it has two x-intercepts. So we're just looking for those x-intercepts today. The real solutions are those x-coordinates for where it crosses the x-axis. We're going to be using graphing today to check your work to make sure that you are solving it correctly algebraically. And the other thing that I want to point out is that the y-coordinate of any point on the x-axis, so anytime you're on that x-axis, the y value is always going to be 0. So when we find solutions, we're always going to have our quadratic equation set to equal 0 because that's going to tell us where it crosses the x-axis. Okay, so the zero product property. It says if you have two factors that are being multiplied together and those two factors equal 0, then either the first one is equal to 0 or the second one is equal to 0. So if you think about that for a second, if I have 3 times some number is equal to 0, this some number has to be 0. And it doesn't matter which order you put it in. I could say some number times 3 is equal to 0. What's this number? It has to be 0. So if we look at a set of factors, x plus 3 times x minus 4 is equal to 0, that means that either the first term or the first factor or the second are equal to 0. Either x plus 3 is 0 or x minus 4 is equal to 0. So if I simplify each of these individually, I can subtract 3 from both sides there. It gives me x is equal to negative 3. I can add 4 to both sides on this one, and that gives me x is equal to 4. So my solutions to this expression are negative 3 and positive 4. So let's put this together with solving quadratics. The first step when you're solving quadratics using the zero product property is that you need to set it equal to 0 so that we can find where the x-intercepts are. So on this one, we need to add 5 to both sides. Be sure that on the left-hand side in this case, you are adding like terms. Don't add this negative 6 and 5 together because this 5 does not have an x value with it. So this is going to be x squared minus 6x plus 5. After you've moved everything over to one side so it equals 0, then you factor it. So if we're looking at this one, we are working with a trinomial that has a 1 as a lead coefficient, which means this is going to be x times x to get x squared. All the things that I can multiply together to get 5, it's just 1 times 5. I have to use 1 times 5. And my signs are going to be the same because this is a plus sign. So in order to add them and get negative 6, both of them have to be negative. So I factored it completely. Notice that I did not lose this is equal to 0 here. When you move on to calculus in the AP calculus exam and those sorts of things, this is really important. When you factor, be sure that you continue to keep the equation. Don't lose the equation and write it like that. Leave this equals 0 tacked on to the end. Okay, so now we're going to use the zero product property after we factor. If these two things being multiplied together are equal to 0, that means either x minus 5 is equal to 0 or x minus 1 is equal to 0. So simplifying those, x is equal to 5 or x is equal to 1. Now, if we want to check our answers to verify that these two solutions are solutions, we can always graph. So if we think about this standard form equation that we have up here, to graph it, you have to look at the vertex. Negative b over 2a is how you find the x value of the vertex and the axis of symmetry. So that's negative 6 over 2 times 1, which is a. So that's 6 divided by 2, which is 3, which means the axis of symmetry is on the line x is equal to 3, and our vertex is going to be somewhere on that axis of symmetry. To find the y value of your vertex, you plug the x value in. So we're going to take the 3 and we're going to put it in. So we're going to do 3 squared minus 6 times 3 plus 5 and evaluate that. Boy. Alright, so 3 squared is 9, 6 times 3 is 18. When I simplify that further, I get negative 9 plus 5, which is negative 4. That means that my vertex is 3, negative 4 then. So 3 down at negative 4 is my vertex. Because the a value is 1, that means that this follows the same pattern as the parent. So it looks like that is going to be my parabola. Comparing this graph and the x-intercepts to the two solutions we just drew a box around, notice that it crosses the x-axis at 1 and 5. So both of those are correct. All right, let's go and look over at a few more practice problems. Okay, so for this first one, x squared minus 16x plus 48 is equal to 0. It's already set equal to 0, so we're ready to factor and then use the zero product property. So factoring, the lead coefficient is 1, which means we have x times x. 48, let's list out all the factors there. We could do 1 times 48, we could do 2 times 24, we could do 4 times 12, and I'm going to stop right there because I see something that I really like. To get negative 16 with the same sign, I can use negative 12 minus 4. So that means both of these are going to be negative signs. The 12 and the 4 are going to go in that second spot. And now we can use the zero product property. So either x minus 12 is equal to 0 or x minus 4 is equal to 0. So x is equal to 12 and x is equal to 4. And those are my final answers. Again, we can graph to check your work. Let's look at number 2. What do you notice is different about number 2? Do you see that we first have to move this negative 4 over to the left-hand side, set it equal to 0? So if we do that, we have x squared plus 4 is equal to 0. Now if I need to factor this is a special one, but there's a problem with it. We have perfect squares, x squared and 4, but notice that this is a plus sign in between. That means this is not a difference of perfect squares. It is a prime polynomial. It cannot be factored. Because of that, that means that I need to revert to another method of solving. Remember before we started factoring, we were working with the square root method, and that's what we're going to use here instead of the zero product property. So remember, for the square root method, you have to isolate the squared term, which we already have. We have the squared term is equal to something else. We're going to take the square root of both sides, so that leaves us with x is equal to plus or minus the square root of negative 4. And then I need to simplify that radical. The square root of 4 is 2, and the square root of negative 1 is I. So our answer is plus or minus 2i. Okay, let's look at the next one. For number 3, everything is already on the left-hand side. It's equal to 0, so I need to factor this one if I want to use the zero product property. The lead coefficient is 4, and there's no GCF that I can take out, which means I cannot factor this one without grouping things together. So to group things together, I need to do a times c, which is 4 times 2, and then I need to list out all of the possibilities here. So I can do 1 times 8, I can do 2 times 4. If these have to use different signs to add together to get 7, that means I'm going to use 1 times 8, because 8 minus 1 is 7. For factoring by grouping, I need to rewrite this term. So I'm going to write 4x squared
plus 8x minus 1x minus 2 is equal to 0. So notice here, instead of 7x, I used this information over here to write down my new 7x, 8x minus 1x. Now for the grouping part, I'm going to group together the first two, and I'm going to group together the last part, those terms, and factor out a GCF from each. In this first part, I can factor out a GCF of 4x. That leaves me with x plus 2. And in the second one, I have this negative 1, and I need to factor out that negative sign. So I'm going to factor out the negative 1, and that leaves me with x plus 2. Now this is a good sign. My two leftovers, they match. They ought to match. That is my first factor, x plus 2. And my second factor is these pieces, the GCF out front, 4x minus 1. Okay, so now from here, I have factored everything. I still need to use the zero product property. So I'm going to write x plus 2 is equal to 0, or 4x minus 1 is equal to 0. Solving these down, you're subtracting 2 from both sides, which gives you x is negative 2. For this one, you need to add 1 to both sides and then divide by 4, which gives you 1/4. So my final answers are x is equal to negative 2, or x is equal to 1/4. All right, let's look at one more practice problem for this method. First, we're looking to factor, which means we are looking to take out a GCF in this case. The GCF is 5x, which leaves us with x plus 4. And now there's nothing else to factor. So I need to set both of the products equal to 0 using the zero product property. Notice that this piece is one of the things being multiplied together. So that means that GCF, 5x equals 0, or the other factor, x plus 4, is equal to 0. So I have x is equal to 0 because 0 divided by 5 is 0. And I have x is equal to negative 4 as my final two answers. Okay, the other thing that I want to quickly remind you is that if I ask you to find solutions, that's the same thing as asking you to find x-intercepts, which is the same thing as finding roots or finding zeros. Solutions, x-intercepts, roots, and zeros, they're all asking you for the same thing. The method that you use to find them will depend on the problem, of course, and your directions. Okay, so let's do a quick review now, where we're looking at all of these methods for solving to find our solutions, x-intercepts, roots, or zeros. So first, if we're solving by graphing, we're going to graph it and then look for the x-intercepts. In standard form, which is what this problem is, you have to find the vertex. To find the vertex, you're looking at the x-axis, or the axis of symmetry first. That's negative b over 2a, which means that is negative 11 over 2 times 1. So that's 11 halves, which for the sake of graphing, I'm going to write that as 5.5. And our y value, we take that decimal or fraction and plug it into the equation to see what y is. So if I do 11 halves squared minus 11 times 11 halves plus 24, let's see what that does. 11 halves squared is 121 over 4. So square both of those values. 11 times 11 halves is 121 over 2. And then I've got that 24 tacked on to the end there. So simplifying further, when I find common denominators, that's going to give me what? Negative 25 over 4 as my total answer. So that's negative 6.25 for the sake of making our graphing easy. Our vertex then is 5.5, negative 6.25. Okay, so let's graph that. It's not the prettiest number, but it's okay. We'll work with it. 5.5 and then down 6 and a little bit more. Puts our vertex there. Now I want to switch and move over to intercept form because it's going to make the rest of this graph significantly easier for graphing because the pattern is not so easy to follow from this kind of awkward point. So I'm going to skip over those zeros for the moment. All right, so in intercept form, that means we need to change this standard form to intercept form by factoring it. So if we factor the problem, x squared is going to be x and x. 24, we have a few options. We can do 1 times 24, we could do 2 times 12, we could do 3 times 8. If I'm looking to use the same signs to get negative 11, I'm going to use 8 minus 3. So both of these are going to be minus signs, or negative 8 minus 3. We've got negative 8 in one, negative 3 in the other. When you're graphing in intercept form, remember the really nice thing about intercept form is that it gives you your intercepts. The x-intercepts are the two values from the factors with the opposite sign. So positive 8 and positive 3. That means here and there are my x-intercepts. And I can graph this now that I also have my vertex. Quick review in intercept form. You can find the vertex by doing p plus q divided by 2. So that's 8 plus 3 divided by 2. And it would give you that same value. Okay, so that was kind of a lot of work solving by graphing. Let's solve algebraically using factoring in the zero product property. I am going to take my trinomial. And because I am looking for the x-intercepts, that means y is going to be 0. And now I'm going to factor. So factoring this, we actually did this just a moment ago with intercept form. So I'm going to have my negative 8 and my negative 3 still there. And now I use the zero product property. So x minus 8 is equal to 0, or x minus 3 is equal to 0. So that gives me that x is equal to 8. And x is equal to 3, which means my solutions are 3 and 8, just like I found as my x-intercepts when you graphed over on the other side. All right, so that is a quick version of the zero product property. You should factor the polynomials using whichever method is appropriate, and then you should apply the zero product property in order to find those solutions. You have a couple of problems at the bottom of your notes that you can go ahead and give a try now.